Okay, good morning, everyone. So for this week, we will be covering the contents of Module 3. Oh, yes, Victor, you have a question?
Napindot lang po, sir.
Okay, no problem. So we'll continue our discussion about polynomial interpolation. Pero I remember last time I asked your lab instructors to discuss the errors involved in interpolation. So how was it? Any questions regarding that? Wala naman. Okay, so because our discussion for today will focus on trying to minimize that interpolation error, okay, or that maximum error incurred in interpolation. So basically, that's what we'll do this week until the 1st of October. So we'll try to cover module number 3, and you'll have your laboratory session on the 4th to focus on the contents of Module 3, which includes laboratory exercise 1.1. If we'll be able to finish discussing the contents of Module 3, then module exercise 1.2 will be due on October 4th, right before midnight. Pero kung hindi natin matatapos and if I will ask your lab instructors to again discuss portions of the module on Monday, then there's a chance that this deadline will be extended. So basically, here are our objectives for the week. You should be able to calculate the Chebyshev and the Legendre polynomials of certain degrees. And then number 2, probably this is more for the problem set to prove some properties regarding Chebyshev and Legendre polynomials, Legendre or Legendre. So nag-shift ako minsan dun sa dalawang pronunciation. So yeah. And then also for the problem set, you should be able to describe why and how the use of roots of these polynomials gives the best interpolating polynomials with respect to some norms. And of course, our goal, which is to use these interpolating polynomials to solve scientific problems. So of course, detailed explanations and discussions can be found in our work text. Sorry, hindi ko nabura yung end others or insert others dito. But yeah, so here we go, norm optimized interpolation. So as I mentioned, the focus of discussion now is to minimize the error involved in polynomial interpolation. So hopefully in the labs, you have seen this error term, right? So if you are approximating a function f using n+1 points, so you will have a polynomial of degree n, all right, or polynomial of degree at most n. Then the error term, when you get f minus p sub n of x, right? So this will represent the error incurred in the approximation at the number x. You will get this term. So let's look again at this term or this expression here. The first factor is just the n+1 derivative. So you take the order n+1 derivative. So that's 1 degree higher than your interpolating polynomial. So n+1 derivative evaluated at some number c over n+1 factorial. And here c is an unknown number on the interval AB. Again, if you went over the proof, you saw probably that this number c is guaranteed by the mean value theorem, which is a result that you probably have just brushed off in your calculus courses, but apparently it has much more theoretical values, like establishing these error bounds. So this is an unknown factor kasi yung number c ay hindi natin alam kung ano yung eksaktong value niya, and that makes the error that makes the error undeterminable kasi hindi natin alam or wala tayong way para ma-compute yung number c. And that is actually a reality. We cannot know the exact error unless we know the exact value. So kung meron kang ina-approximate na data set, hindi talaga natin malalaman yung eksaktong error that is incurred in the interpolation because the error term here involves this value c, which is unknown for us. Okay. And then the second factor here is actually a product of terms or factors of the form x minus x sub I. So basically, ito lang yung basically this is a degree n+1 polynomial which has leading coefficient equal to 1. So altogether, these two factors give us the error, the exact error for the interpolation. But again, we cannot get our hands on this or on the exact value of this this expression kasi nga gawa ng number C. Okay, that's why when we consider errors or error bound or error estimates, we always look at the largest possible error. So kaya dun sa, I think dun sa discussions you look at the maximum of the absolute value of this this expression. Bakit natin kinukuha yung maximum? Because if we get the maximum value or the maximum absolute value of this expression, we are getting the worst case error. So kaya ang tawag natin lagi sa error estimates natin ay error bounds. Kasi kinukuha natin yung pinakamalaking posibleng error because it's more insightful to look at the worst case scenario or the maximum possible error than looking at the minimum possible error. Kasi kung yung maximum error yung titingnan natin, alam natin na yung error hindi lalampas doon. So we will have an idea how far off or how bad our approximation can become. And if we will get a very small error bound, then we are guaranteed that we get a nice approximation. Kasi yung maximum, yung pinakamalaking posibleng error ay maliit, ibig sabihin kahit anong mangyari, maganda yung approximation natin. In contrast, if you will compute the minimum of this expression, pag kinuha mo yung minimum ng expression na to, what you will get is the best case scenario. Na ano yung pinakamaliit na posibleng error, but there's no guarantee that you can attain that minimal error. So pag sinabi mo na, ang minimum error ko ay 10 to the minus 6. Pero there's no guarantee that you will get an error as good as 10 to the minus 6. Okay? Pero kung sabihin nyo na ang maximum error ko ay 10 to the minus 3. So kahit anong man ang mangyari dun sa approximation mo, even how crazy the value of x at which you want to evaluate or estimate the function at, alam mo na kahit ano pa mangyari yung error, hindi lalampas ng 10 to the minus 3. So you see how more insightful it is to look at the maximum of this expression rather than the minimum. Na minsan naglo-lurk kasi ako dun sa mga lab sessions niya. Pag available yung recording, pinapanood ko rin siya minsan, lalo na yung Q&A. So para kung merong magandang question dun sa mga Q&A, pwede kong i-bring up sa lecture. And I guess this is one of the questions there. So hopefully I answered or we answered your questions satisfactorily. So, okay. So our goal is to minimize this expression. Or actually, we can worry about minimizing this term first. Forget about the maximum for now. So, isang gusto natin, syempre, mapaliit yung error term. Okay? Pero paano natin mapapaliit yung error term? Well, there are two factors involved, so we can look at minimizing each one of them while keeping the other one constant. Kasi you will see later na medyo independent naman tong dalawang factors na to. So let's look at the first factor. Of course, we cannot do anything about the function f. Kasi yung function f, yan yung gusto nating i-approximate. So that's given in the problem. Now, c is an unknown parameter from AB, and the closed interval AB is also given in the problem. So in this factor, the only thing that we can vary is the value of n. Okay? And what is the value of n? Siya yung number of data points. Of course, it's not always possible to mess with the number of data points, lalo na kung galing ka sa experimental data or limited yung data, given kagad na say 500 yung data points mo. So you cannot do anything about it. But if you have the option or if you have the freedom to play with the value of n, then what do you think can be done para ma-minimize tong error na to? Anyone? Ano kaya yung pwedeng gawin? Yung unang makakasagot, +1 sa problem set. So kung gusto kong i-minimize itong factor na to, with n as the degree of freedom, okay, pwede kong baguhin yung n, pwede kong paglaruan. Ano kaya yung pwede kong gawin kay n? Actually, even if you don't know the formula, a little bit of intuition can help you get the answer I'm looking for. Ano yung pwede natin gawin kay n para mapaliit yung error?
Hello, sir. I-increase po ba yung n?
Oh, great. That's correct. Thank you, Lyra. So, i-increase si n. Kasi pag in-increase natin si n, yung numerator, n plus 1 derivative lang naman evaluated at psi. So, it will stay as a constant. Okay? Now, if you increase n, yung denominator is n plus 1 factorial. And if you remember from the Bachmann-Landau equation, halos lahat ng function na outgrow ng n plus 1, ng n factorial. So when n increases, there's a big chance that this guy will be offset by the increase in the denominator. So kahit lumaki man yung numerator by taking n larger, ma-offset naman yon by the rapid growth nung factorial, nung n plus 1 factorial. So n plus 1 factorial will tend to become a very large number at a very fast rate. So this guy has more chance of going to 0 when n is larger. And this guy is also, there's a chance that this will increase, but this will entail a polynomial increase. Kasi ito naman ay x to the, kakaroon ka ng x to the n plus 1, right? Pero remember that factorials outgrow polynomials. So ang isang polynomial, say x to the n, siya ay big O ng n factorial, right? For any polynomial, any value of n. So mas mabilis lumaki lagi yung mga factorials. So any increase in the magnitude of this guy or of this guy can easily be offset by taking the factorial, okay, or by the rapid growth of the factorial. So that's one way. We can increase the number of points. And it kind of makes sense kasi remember, kapag ka nag-interpolate ka, kailangang dumaan dun sa interpolatory points yung interpolating polynomial. So kung marami kang dots na sinusundan, there's a bigger chance that you'll be able to trace the graph or the function more in a better fashion. Kasi marami kang dots na kailangan daanan. So ibig sabihin, yung makukuha mong interpolating polynomial, magiging mas kamukha ng function na ina-approximate mo. Okay? So, but that seems to be a good strategy. But in the next discussions, we will try to see meron ba talagang problema kapag ka pinalaki ko yung value ni n. Okay? But for now, we'll focus our discussions on the second term. How do we minimize the second term? And I guess in the latter part of module 2, tinawag natin tong omega of x. Okay? So we want to focus our discussion on minimizing omega with respect to some measure of error. So ano ba yung properties ni omega? Well, we have said omega is a polynomial in x. Tapos degree n plus 1 siya. So ang itsura niya ay 1 times x to the n plus 1 plus some more factors until makarating ka sa constant c sub 0, right? Ang alam ko lang sa mga coefficients nila yung leading coefficients or yung coefficient ng highest degree term. Kasi lahat ng mga x's, ay degree 1 lang naman. So magkakaroon ako ng x to the n plus 1 plus, hindi ko na alam yung mga susunod na coefficients, but I know this is of degree n plus 1. And then this depends on the exabytes. Okay? So, ibig sabihin dito, sa second factor, ang degree of freedom lang natin ay exabytes. So if we want to minimize omega, we can only do so by choosing the exabytes in a nice way, right? Pero ano nga ba yung exabytes? Sila yung interpolatory abscissa. So if you want to mess with the second factor or this omega here, so if we want to minimize this, our degree of freedom or our degrees of freedom would be the exabytes. How can we choose the exabytes properly in order or optimally in order to get a minimal error? Tapos yun yung titingnan natin ngayon. Ano kaya yung mga okay na gamiting exabytes? Again, this approach has a big drawback. Kasi paano kung wala ka naman choice sa mga exabytes? So kung wala kang choice sa mga exabytes, then pupunta ka dun sa first factor. Dito sa derivative factor. Pero pag wala ka ring options na baguhin si n, then that's the best interpolation can offer. But again, this is still useful. This approach is still useful because paano kung given a function, komplikadong function, ayaw mo siyang i-integrate, ayaw mo siyang i-differentiate, then you can use interpolation. And if you know the function, it's easy to compute function values. So you just need to choose the x. You can choose the exabytes, and actually you can also choose the number of points to be used. So that's what this module is devoted to. We will look at ways on how to minimize omega, or actually we will look at two ways how to minimize omega or the magnitude of omega, and we'll do so with respect to two measures of error. So we'll look at error. We'll look at the error in a local and a global fashion. So we'll begin with looking at it in a more local fashion, and that is what we call the Chebyshev interpolation. So here we are greeted by definition 1, which is basically defining what the L infinity or the supremum norm is. Okay. So if you have a continuous function over the interval AB, let's say it's f, right? Then the L infinity norm of f, we denote by this, double bars, then a subscript infinity. This is equal to the supremum of the absolute values of f of x over the interval AB. So kukunin nyo lang yung pinakamalaking absolute value ng f over sa interval AB. Now we know that since f is continuous, by the extreme value theorem, we know that it will attain a maximum value over the interval AB. Or siguro before that, I must say na if f is continuous, then its absolute value is also continuous. And then by the extreme value theorem, kapag continuous yung function mo sa isang closed interval, nag-attain siya ng isang maximum value over that closed interval. So that's why this supremum here is well defined. Lagi nating mako-compute yung supremum na yan. So if you have, say, if your function looks like this, okay? Let's say ito yung interval AB. Oops, dapat diretso ko siya dyan. Tapos ito si A, alright? So kunin nyo lang yung pinakamalaking magnitude. So in this case, sa pangit kong drawing dito, it looks like this will give me the maximum absolute value. So computein nyo lang to. Then take its function value, take the absolute value, then that would be the supremum. Okay, so imagine what will happen if I will I will compute the L infinity norm of the error. Pag kinompute ko yung L infinity norm ng error, ibig sabihin ibibigay niya yung maximum error na na-incur over the interval AB. So that's what makes this measure of error more local in nature, kasi kinukuha natin yung maximum error dun sa interval AB. And we let this to be the measure of error. Well, if we compute the L infinity norm of the error, then if we minimize it, ibig sabihin bababa yung maximum possible error. So pag bumaba yung maximum possible error, then all throughout the interval AB, napababa rin natin yung error. Kasi napababa natin yung maximum, so bababa rin yung error dun sa buong interval AB. But again, the L infinity norm is a more local measure of error. Okay. Now, so yun yung goal natin, mapababa yung L infinity norm ng error. Okay. And let's look at how to do it. Well, in order to do this, I'll need a class of polynomials, and they are called the Chebyshev polynomials. So we have here in definition 3, a description of the Chebyshev polynomials. So a Chebyshev polynomial of degree n, okay, or of order n, shall be denoted by t sub n of x. So yun yung mga Chebyshev polynomials. Ang kaibahan dito, though they are called polynomials, ang domain niya lang ay from -1 to 1. Okay? And they are given explicitly by this expression. Ang Chebyshev polynomial t sub n ay equals sa cosine ng n r cosine of x. And you will see right away why the domain is from -1 to 1 lang. Kasi yung x, papasok siya dun sa r cos. So, pero r cosine ay defined lamang for x's between -1 to 1 because you're asking what is the angle that will give me that x value for the cosine, right? So, kaya -1 to 1 lang siya. Well, if n is equal to 0, let's see how the Chebyshev polynomials look like. It will be defined for all non-negative integers. So ibig sabihin, we can start at n equals 0. So at n equals 0, we'll have this t sub 0 of x. So we'll have cosine of 0 times r cos of x. So this will be 0. That's 1. So this is the degree 0 Chebyshev polynomial. So this is a constant polynomial 1. And then t1 of x will be cosine of 1 times r cos. So this would be r cos of 1. R cos of x. And then cosine and r cos are inverses of each other. So their composition will just give us x. So the degree 1 Chebyshev polynomial is x, the polynomial x. But again, this will be defined only over the interval -1 to 1. Unfortunately, beyond this, it seems na hindi na magiging polynomial yung Chebyshev, yung t sub n. Kasi halimbawa sa t2, para makompute yung t sub 2 of x, plug in ka lang ng n equals 2, you get cosine of 2r cosine of x. Okay? Mukhang hindi na siya polynomial kasi at this current form, trigonometric siya. Pero here's a trick on how to see really that the t sub n's are polynomial in form. So let's compute t sub n plus 1. Actually, what I'm trying to derive here would be a recursive formula for the t sub n's. Okay? So tingnan natin ano yung itsura ni t sub n plus 1. Of course, dun sa trigonometric definition, I'll just replace all n's by n plus 1. And I'll do another substitution pala. I will let theta be equal to r cosine of x, just for brevity just for the brevity of the derivation. So, okay, see, r cosine x will be replaced by theta. So t sub n would be cosine of n theta, right? And then if I compute t sub n plus 1, I'll replace all n's in here by n plus 1. So we'll get this guy, okay? And then let's simplify let's expand the argument. So we'll get cosine of n theta plus theta. Tapos dito magagamit nyo na yung trigonometric identity na natutunan nyo way back in your trig classes. So the sum, the cosine of a sum will be or can be expanded in this form. Okay. And then I'll do a similar thing for t sub n minus 1. Okay. So yung t sub n minus 1 naman, kung i-expand ko rin in a similar manner, I'll get this expression. Okay. Tapos ang idea dito, gusto ko mawala yung mga signs. Kasi okay na magstay yung cosines kasi sila naman yung nandun sa theta. I can play with it later, right? So that's why I computed t sub n minus 1 in the hopes of eliminating those or this term with only signs in it. Okay. And true enough, kung makikita nyo, negative to, positive to of the same thing, if I add them up, then they will cancel each other out. Okay. And true enough, t sub n plus 1 plus t sub n minus 1 will give me this. Okay. But again, we let theta be equal to r cosine of x, taking the cosine of both sides will give us cosine theta equals x. So using this info in this expression, I can replace cosine by x. So that means we'll get 2x times cosine n theta. But if you go back, cosine n theta is nothing more but t sub n of x, right? So there you go. After the substitution, we found out that t sub n is just cosine n theta. So basically what we found out is t sub n plus 1 plus t sub n minus 1 is just 2x times t sub n. Okay, good so far. Puro algebraic manipulation lang naman to so far. And then I can play with this equality. So I can what? I can subtract t sub n minus 1 from both sides and come up with this. So basically, this is an example of a recursive formula, which means we use previous values of t sub n in order to compute a new value for t sub n, or a new value of the next polynomial in the list. So here, to get t sub n plus 1, we are using t sub n and t sub n minus 1, two previously calculated t sub n's. Okay, so okay na to kasi alam natin si T1, alam natin si T1 at saka si T0. So with that knowledge, I can compute for T2. So according to our derivation, T sub 2 ay equal lamang kay 2x, the previous Chebyshev polynomial, so that would be T1 of x, minus the Chebyshev polynomial 2 steps back. So this would be T0 of x. So this would be 2x times x minus 1, right? Kasi yung T1 ay x, yung T0 ay 1. So basically, this is 2x squared minus 1. That's the degree 2 Chebyshev polynomial. And then you can compute T3. T3 of x would be 2x of the previous Chebyshev polynomial minus the Chebyshev polynomial 2 steps back. So that would be T1. So this would be 2x times 2x squared minus 1 minus T1, which is x, right? So this would be 4x cubed minus 2x minus x, so minus 3x, right? So is it clear how we are deriving the Chebyshev polynomials? All right, thank you. And then if you want to play with it, so I think I listed here the first 8 Chebyshev polynomials. So you see 1x, 2x squared, 4x cubed, minus 3x, and so on. So recursive yung definition ng Chebyshev polynomials. And again, now it's clearer to us that indeed the Chebyshev polynomials are polynomials. Or sorry, polynomial-like. Kasi ang domain ng Chebyshev polynomials ay -1 to 1 lamang, right? So again, these are only defined on the interval -1 to 1. Okay? Kasi by definition, cosine to ng NR cos. This polynomials is just another way of writing the expression T sub n, but they will inherit the original domain of the Chebyshev polynomials as defined. So domain niya lang, -1 to 1. All right. Now, what are certain things that we can discern from this table? It seems that the pattern is that si T sub n is degree n. Okay. Madali naman siyang i-prove kasi yung T1 ay degree 0. Yung T0 ay degree 0. Yung T1 ay degree 1. Tapos, how do we get the next T sub n's? So, at least dito sa table, ang T2 ay degree 2, T3 ay degree 3, T2 ay T4 ay degree 4, and so on. It seems that the pattern will all hold on. But if you want to write a formal proof of indeed T sub n is of degree n, makikita nyo na, remember, ang T sub n plus 1 ay equals to 2x T sub n minus T sub n minus 1, right? So, pwede kayong mag-induction dito. So, first few examples, basis step, check. Gawa na natin. So, at least kapag si n ay 1, alam natin siya ay degree 1. Pero pag inassume natin na si Tn ay degree n, hypothesis of induction, so ito ay degree n. Pero anong mangyayari para makompute si Tn plus 1? Para makompute si T sub n plus 1, etong degree n polynomial na to, minumultiply ko ng 2x. So, this term is degree n plus 1. Kasi nadagdagan siya ng isang degree kasi nag-multiply tayo din ng x. Tapos, itong T sub n minus 1, ang degree niya ay n minus 1. So, there is no chance na makakancel niya yung term na may x to the n plus 1 dito sa unang term. Kasi ito ay degree n minus 1 lamang, wala siyang x to the n plus 1. So, indeed, this guy will be degree T sub n plus 1. Okay? So, isa to sa mga properties, pwede ko siyang ipa-prove sa problem set. So, you can try writing the formal proof, and the proof is via induction in that same manner as I have described. Okay? Now, ano pang pwede nating i-observe sa T sub n? Well, if you notice, starting from n equals 2, hindi na 1 yung leading coefficient, right? So, T2, ang leading coefficient ay 2, T3 leading coefficient ay 4, T4 leading coefficient 8, T5 leading coefficient 16, and so on. So we can say for n greater than or equal to 2, t sub n is not monic. Have you guys encountered the term monic polynomials? Siguro sa 111, kung nag-111 na kayo. So we say a polynomial is monic kapag yung leading coefficient niya ay 1. So like x or x squared plus 2x, x cubed plus 2x plus 1. Basta yung leading coefficient, yung coefficient ng term with the highest degree, ang coefficient ay 1, ang tawag sa kanya ay monic. Pero otherwise, we call it a non-monic polynomial. Okay. So hindi na siya monic, and in fact, ang leading coefficient ay what? 2 to the power, ano kayang leading coefficient? 2 to the power 1. Kasi as we have observed here, lagi siyang power ni 2. Pero ano ang leading coefficient ni Tn, ni T sub n in general? Anyone? Plus 1 ulit sa prob set. Anyone pala aside from Lyra? Kasi nakasagot na si Lyra. Ano yung leading coefficient ni T sub n? Anyone? Tingnan nyo lang yung pattern. Or hindi pa gumagana yung brain cells kasi hindi pa kayo nakapagkape. Kaya ako nagpapa-recitation para makapagkape ako on the side. Okay, if nobody wants to answer, sige, let's analyze. So, kapag ka degree 2, ang leading coefficient ay 2. Kapag ka degree 3, ang leading coefficient ay 4, which is 2 squared. Kapag ka ang degree ay 4, ang leading coefficient ay 8, which is 2 cubed. Kapag ka ang leading coefficient, kapag ka ang degree ay 5, ang leading coefficient ay 16, 2 to the 4th. So it seems that T sub n will have leading coefficient 2 to the n minus 1. Right? So hindi siya monic, tapos ang leading coefficient niya ay 2 to the n minus 1. Okay? And it's easy to prove that, again, by induction. Kasi paano natin nakukuha yung leading coefficient? Nakukuha natin yung leading coefficient by looking at the term with the highest degree. So, ibig sabihin, manggagaling yon dito sa term na to. So, ang highest degree ni 2n plus 1, manggagaling sa 2 to the n. Manggagaling sa leading coefficients ni t sub n. So, kung ito, i-accept natin as hypothesis of induction na may leading coefficient na 2 to the n minus 1, right? As per our observation, meron ka pang multiplier 2 dito. So yung term na 2 to the n minus 1 x to the n na nanggagaling kay tn, namumultiply siya ng 2x. So ibig sabihin, ang leading coefficient na nanggagaling dito ay magiging 2x times 2 to the n minus 1 times x to the n. So magiging 2 to the n, x to the n plus 1. Right? And indeed, the degree is 1 higher than the power of the leading coefficient. Right? Kaya laging 1 degree less, 1 less than the degree yung exponent ng leading coefficient. Okay? Now, these properties are summarized in remark 3.1. Okay? So degree n, hindi siya monic, ang leading coefficient niya ay 2 to the n minus 1. Now, some other properties, T sub n is even when n is even, and it is odd when n is odd. And then of importance to us are properties 5 and 6. Okay? Ano yung sinasabi ng properties 5 and 6? Property 5 gives us the roots of the Chebyshev polynomials. So ang roots ng Chebyshev polynomial, ganito pala yung itsura. Cosine lamang sila ng 2j minus 1 over 2n pi for j going from 1 to n. And actually, madali itong i-prove using the cosine definition. So para makuha yung roots, remember, ang ginagawa lang natin, in-equate lang natin yung gusto nating hanapan ng root kay 0. But T sub n via the cosine definition is cosine of n r cosine of x. And then you'll solve it Math 17 or your high school algebra style. Kailan nagiging 0 ang cosine? Nagiging 0 ang cosine kapag yung angle sa loob niya ay what? Nag-0 kapag odd multiple ni pi over 2, right? So the angle inside cosine should be an odd multiple of pi over 2. So pwede ko siyang isulat na 2k minus 1 pi over 2. Okay. Where k is an integer. Okay. And then, i-divide ko both sides by n. Tapos, nabura yung arcos. Okay. I-divide ko by n. Tapos, I'll take the cosine of both sides. Ito lang to. Kinuha ko yung cosine ng both sides. Pero that will simplify the left-hand side. Kasi meron kang cosine followed by an arcos. So, matitira lang dito sa kaliwa ay x. So x's that will make the Chebyshev polynomials equal to 0 would be of this form. Cosine ng 2j minus 1 over 2n times pi. So dyan siya nagsi-0. And there would be how many? There would be n of them. As expected, because degree n yung t sub n, so it will have at most n roots. Pero sabi dito, it will have n simple roots. So ibig sabihin, ganun karami. Kung ilan yung degree, ganun kadami yung zeros ng Chebyshev polynomial. Okay. Another nice thing about the Chebyshev polynomials is that we know kung ano yung maximum value nila on its domain, which is -1 to 1. Okay. Dahil ang Chebyshev polynomial ay cosine ng isang angle, right? Isang radian value, right? Cosine siya of something. So therefore, ang maximum value niya lang ay plus or minus 1. Okay? At nangyayari yon, madiderive nyo kung kailan na-attain yung extreme values na yon kapag ka inequate nyo yung t sub n kay plus or minus 1. So palitan nyo lang lahat dito ng plus or minus 1. And then here you will be asking the question, when is cosine plus or minus 1? Na-attain ni cosine yung maximum niya kapag ang angle niya ay multiple ni pi. Like 0 pi, 2 pi, 3 pi, 4 pi, and so on. So you can say the angle here should be equal to k pi for some integer k. Right? And then you do the same simplification and you will see that the maximum is attained at numbers of the form cosine of j pi over n, j going from 0 until n. Okay. And then this tells us there are n plus 1 points wherein we get the extreme values of 1 and positive 1 and negative 1. Okay. All right. So probably in the problem set, I'll pick one of these properties tapos ipapaprove ko sila sa inyo. So you can start checking the proof or writing the proof of this down. Kasi yung problem set naman ay take home. So pag ginawa niyo na siya early, kokopihin niyo na lang siya pag nagbigay na ako ng problem set. So you can try this or you can try writing the proof for these statements. Okay. Now, para saan yung Chebyshev polynomial? So anong connect ng Chebyshev polynomials dun sa goal natin? Remember, our goal is to minimize omega. But before we go there, or certainly go there, i-define ko muna yung monic version ng Chebyshev polynomials. Again, when we say monic, ibig sabihin 1 yung leading coefficient. At alam natin yung Chebyshev polynomials, ang leading coefficient niya or nila ay form 2 to the n minus 1. So para maging monic yung Chebyshev polynomial, pwede ko siyang i-scale. Pwede kong i-divide yung buong polynomial by 2 to the n minus 1. Pag divide ko siya by 2 to the n minus 1, ang leading coefficient niya na magiging 1. Magiging monic na siya. So we will denote the monic version of the Chebyshev polynomials by t hat sub n. So lalagyan lang natin ng hat yung variable t that stands for the polynomial. Okay. Tapos ganito yung definition niya. Right? So kapag ka hindi siya monic, i-multiply ko lang siya ng 2 to the 1 minus n. Okay. But the nice thing about scaling a polynomial, hindi nagbabago yung roots. Kasi kapag ka si x ay root, so if x is a root of t sub n, then we know that t sub n of x will be 0. And then if I multiply both sides by 2 to the 1 minus n equals 0, ibig sabihin itong 2 to the 1 minus n times t sub n, ito ay equal kay t hat sub n of x, equal pa rin kay 0. So kung ano yung roots ng Chebyshev polynomial, siya rin yung roots ng monic Chebyshev polynomial. So invariant yung roots up to scaling. So hindi natin nabago yung roots. Tapos hindi rin natin mababago yung minimizers at saka maximizers ng Tn. So meaning kung ano yung maximizers or minimizers ng Chebyshev polynomial, yun din yung para sa monic version. Nagbabago nga lang yung maximum and minimum value. So remember, L infinity norm o yung maximum value ni T sub n. Remember, ang L infinity norm ay yung maximum lang ng absolute value. Pero alam natin yung maximum ng T sub n ay ang maximum at minimum ng T sub n ay plus or minus 1. Pag kinuha niyo yung absolute value, that means the supremum of T sub n of x. So maybe I should write that down. Supremum ng absolute value ng T sub n of x in the interval negative 1 to 1 ay equal lang kay 1. Kasi ang maglalaban lang naman dito absolute value ng maximum at saka absolute value ng minimum. Pero ang maximum at minimum natin plus and minus 1. So if you take the absolute value, tied sila sa 1. So ito yung supremum ng absolute value. At remember, this is our definition of the L infinity norm. Okay. So that tells us that the L infinity norm of the Chebyshev polynomials is equal to 1. Okay. Now, pag kinuha natin yung L infinity norm ng T hat sub n, ibig sabihin yung constant multiplier dun sa T sub n, lalabas lang siya ng pagkuha nung L infinity norm. So to get, sorry, may typo doon, nawala yung sub-infinity. So that will mean that the maximum or the supremum or the L infinity norm of T hat sub n ay equal lamang sa 2 times 2 raised to 1 minus n ng L infinity norm ni T sub n. But we know that this is equal to 1. So basically this is 2 to the 1 minus n. Okay, so ang L infinity norm ni monic Chebyshev polynomial ay 2 to the power 1 minus n. Okay? Pero nangyayari rin sila, or this maximum value is attained at the z sub j's na maximizer at minimizer ni Chebyshev polynomial. Okay, hindi sila nabago. Okay, now ito na yung promise kanina na magagamit natin somewhere ang Chebyshev polynomial sa pag-minimize ng omega nung isang factor dun sa error term sa polynomial interpolation. The answer is in Theorem 3.1. Theorem 3.1 tells us that if the monic Chebyshev polynomial of degree n attains the lowest L infinity norm among the class of monic polynomials of degree n. So take some time to read this theorem 3.1. Ang gustong sabihin ng theorem 3.1, kapag kinolekta natin lahat ng monic polynomials of degree n, lahat sila, tapos kinuha ko lahat ng L infinity norm nila, it is guaranteed that the monic Chebyshev polynomial will get the smallest L infinity norm. Okay? So, siya yung may minimal L infinity norm. And let's try to write a proof for this. Sana matapos ko siya in 5 minutes. Pero mukhang manghingi uli ako sa inyo ng 5 or 10 minutes na extension. But anyway, okay. So, proof. And I'll do it by contradiction. So usual, pag sinabi mong minimum, siya yung may pinakamaliit na L infinity norm, let's write a proof by contradiction. So let's suppose there exists a polynomial P of degree n. Sorry, not just a polynomial, but a monic polynomial of degree n, such that its L infinity norm is smaller than that of the degree n monic Chebyshev polynomial. Okay. So kunwari, merong polynomial of degree n na monic at saka mas maliit yung L infinity norm kaysa kay monic Chebyshev polynomial. Again, remember ang L infinity norm ni monic Chebyshev by 2 to the 1 minus n. Okay? Now, I will define a function q as t hat sub n of x minus p of x. Okay? Now, what can I say about the degree of q? Ano kaya yung degree of q? Okay, so what we know, alam natin si t sub n ay monic degree n, si p ay monic of degree n. So ibig sabihin, ang leading coefficient dito ay x to the, or ang leading term kay t hat sub n ay x to the n. Leading coefficient kay p, dahil siya ay degree n at monic din siya, meron siyang x to the n. So q then will have something will have an expression like x to the n minus x to the n. So ibig sabihin, maka-cancel yung terms na x to the n kay q. So that leaves q with degree with the leading term of with coefficient at most x to the n minus 1, right? Kasi na-cancel yung x to the n. So si q magiging degree at most n minus 1. Nabawasan siya kasi yung mga x to the n dito sa dalawang components na to ay na-cancel. Right? So siya ay degree at most n minus 1. Then let's zj be the minimizers. Not just the minimizers and maximizers of t hat sub n, right? So si CJ, sila yung mga maximizers at minimizers ng monic Chebyshev polynomial, right? So alam natin here j goes from 0 to n. We go back to Theorem 3.2. Ito yung mga CJs na maximizers at minimizers ng monic Chebyshev polynomial. J goes from 0 until n. Okay. So sila rin yung mga CJs na tatawagin ko dito. Now I want to look at them because I'll look at Q of Zj. So Q of Cj is t hat sub n of Cj minus p of Zj, right? Pero this guy will be 2 to the 1 minus n times either plus or minus 1, di ba? So yung Chebyshev polynomial, nag-plus 1 lang siya or nagma-minus 1 siya dun sa mga values ni Cj. So actually, this will be negative 1 to the power j. Yung j yung nagde-determine ng sign niya kung siya ay positive or negative. Minus p of zj. So, yeah, that would be q of zj. Now, there are two options. J can be odd or even. So let's start with case 1. If j is even, then what do we get? Q of zj would be 2 to the 1 minus n minus p of zj. Okay? Si j ay even, so this factor becomes 1. Ito lang yung meron tayo. Okay? But what can I say with this value, or the value of q of zj? So this is 2 to the 1 minus n. That's a constant right away, except for n. Pero anong masasabi natin kay p of zj? Kung si P of Cj ay negative, so this would be 2 minus a negative number. So the difference would be a positive number, right? Pero kung positive si P of Zj, kung positive to, baka magka-problema tayo na maging negative ito. Pero remember that P of Cj, or P is a polynomial, na ang supremum niya ay mas maliit kay 2 to the 1 minus n. So ang maximum value ni P ay hindi pwedeng lumampas ng 2 to the 1 minus n. Right? So ito pala, hindi siya lalampas ng 2 to the 1 minus n. So 2 to the 1 minus n minus something less than 2 to the 1 minus n will be positive. Right? Okay, I hope that's clear. And then similarly, if j is odd, parang Q of Cj equals negative 2 to the 1 minus n minus P of Cj. Okay. If P of Cj is positive, then this guy is automatically negative. All right. But if P of Cj is negative, magkakaroon tayo ng negative plus positive. Pero again, the value of negative P of Cj cannot exceed negative 2 to the 1 minus n. It cannot be less than 2 to the 1 minus n. Kasi hindi siya pwedeng mas maliit sa 2 to the mas maliit sa negative 2 to the 1 minus n. This difference will be less than 0. Will remain to be negative. Okay? So ang idea dito ay kapag ka si j ay even, si Q of Cj ay positive. Kapag ka si j ay odd, negative naman yung value niya. So if we try to sketch the graph of Q, okay. Posibleng ganito yung itsura niya with respect to the Zj. Halimbawa ito si Z1. Dahil si J ay odd dito, yung Q ay dapat negative yung value. So, might be somewhere here. Si Z2, si J ay 2 even, so dapat si Q ay positive. So, it might be somewhere here. Z3 has an odd subscript. So, posibleng value ni Q ay andito sa ilalim. Z4 could be here. Positive siya dapat kasi J is even, and so on. So the graph of Q might look like something like this. Right? So kunwari meron ka pa ditong Z5. So this is the graph of Y equals Q of X. Okay. Now, what do we know more about Q? Q is another polynomial, so it is continuous. So kaya kailangan ko siyang i-drawing without lifting my pen kasi continuous yung function. And what can we observe? Kay Z1 siya ay negative. Kay Z2 siya ay positive. But since f is continuous, then by the intermediate value theorem, dahil dire-diretso ko siyang dinodrawing, continuous siya from Z1 to Z2, dapat there is a point between Z1 and Z2 kung saan nag-intersect siya sa x-axis. So that means there should be a root between Z1 and Z2. And then, similarly, Q was positive at Z2. It is positive at C3. So, ibig sabihin, again, by the intermediate value theorem, dahil continuous yung function, dapat magi-intersect siya dun sa x-axis. And again, there will be another root here. So, this is root 1. This is root 2. And that will also happen here. Ito yung root 3. Ito yung root 4. And so on. So, ilan yung roots na makukuha ko? Kung meron akong n plus 1 na mga j's kung saan nag-alternate. So remember, j's goes from 0 to n. So ibig sabihin meron akong n plus 1 na mga j's. Tapos nag-alternate yung mga q of cj's from being negative to positive. Tapos ito yung illustration niya. Ilan roots yung meron si q? Again, plus 1 sa prop set. Ilan yung roots ni q? Any guess? Any guesses?
Sir, paulit po ng question. Ay, ayan.
Yan, ilan yung roots ni Q? Oh, Denmark, yeah. Oh, thank you, Denmark. That's correct. So, +1 ka din. So, meron kang n roots. Kasi halimbawa, from Z1 to Z2, meron akong dalawang Z's, may isang root. Kung meron akong Z1, Z2, and Z3, meron dalawang roots. Tatlong beses siya nag-alternate. Positive, negative, positive. So, ibig sabihin, may dalawang beses na nag-cross siya ng x-axis. And if you extrapolate the process, you will see na, okay, kung meron akong n+1 na beses na nag-alternate siya from positive and negative, ibig sabihin, dumaan siya sa x-axis n times. So that means Q will have n roots. So Q has n roots. And I say this is a contradiction. Bakit siya contradiction? Contradiction siya kasi, ano yung alam natin? Si Q ay degree n-1. Right? And yet, it has n roots. So, pero sabi ng fundamental theorem of algebra, kapag ka meron kang polynomial of degree n greater than 0, ibig sabihin, meron ka lang at most n roots. Meron tayong degree n-1 polynomial Q, pero meron siyang n roots. So, Q must be the 0 polynomial. Alright? At dahil si Q ay 0 polynomial, so that makes P of x, or ano nga ba definition ni Q? Si Q ay T hat sub n of x minus P of x equal to 0. That means T hat sub n of x is equal to P. So equal lang pala yung Chebyshev polynomial dun sa polynomial P, which is again another contradiction kasi inassume natin na si Pn o si P ay may mas maliit na L infinity norm kaysa kay T hat. Okay? Which is impossible kasi napakita natin na si P dapat equal kay T. Right? So that means there cannot exist a monic polynomial of degree n with L infinity norm less than that of the monic Chebyshev polynomial. So that's why we have theorem 3.1. Ang may pinakamaliit na L infinity norm among the class of degree n monic polynomials ay yung mga Chebyshev polynomials. But again, bakit nga ba ako insistent on this result? Bakit ko gusto yung result na yon? Ano ba yung monic polynomial? Meron ba tayong monic polynomial of concern? I hope you remember our remark earlier na yung omega of x na gusto nating i-minimize. Okay. Ito si omega. Yung second factor dun sa error term dun sa interpolation. Siya ay product ng mga x minus xi. Tapos, may kulang dito. X minus x sub n plus 1. Degree n plus 1 siya. So, degree n plus 1 siya. Tapos, monic din siya. Kasi, pag minultiply ko yung mga x's, yung term na may x to the n plus 1 lamang ay may coefficient 1. So this is monic, as we remarked earlier. Oops, I think sinabi natin to kanina. So if I want to get the minimum L infinity norm for omega, kailangan yung omega dapat maging equal sa monic Chebyshev polynomial. Okay? Pero paano ko magagawang si omega ay maging equal dun sa monic Chebyshev polynomial? Again, gusto ko si omega maging monic Chebyshev kasi yung monic Chebyshev siya yung may pinakamaliit na L infinity norm. But how do I make omega equal to the monic Chebyshev? I can force the issue that the roots of the monic Chebyshev polynomials are also the roots of omega. Okay. So, ibig sabihin yung mga exabytes dito, dapat sila yung maging roots nung monic Chebyshev polynomial. Kasi if that is so, then parehas ng roots si omega at saka si Chebyshev polynomial, and that is invariant under the set of monic polynomials. Kasi remember, yung mga exabytes dito, sila yung roots ni omega. Kapag yung exabytes, ginawa kong equal dun sa roots ng monic Chebyshev polynomial, ibig sabihin omega will be equal to t hat sub n plus 1. Okay. So again, if we choose the interpolatory abscissas to be the zeros of the Chebyshev polynomial or of the monic Chebyshev polynomials, then omega is equal to t hat sub n plus 1. And that makes omega attain the minimal L infinity norm. Dahil si omega ay degree n plus 1, so L infinity norm ay 2 minus 2 to the 1 minus n plus 1. So this would be 2 to the negative n. So kaya ang kanyang L infinity norm ay 2 to the negative n, and we are guaranteed that this is the smallest possible L infinity norm for omega. Okay, kasi yun yung L infinity norm ng monic Chebyshev polynomial, at napakita natin na yung monic Chebyshev polynomial yung may pinakamaliit na L infinity norm. So in summary, what we have established here is that in order to minimize the L infinity norm of omega, we must use the roots of the monic Chebyshev polynomial to be the interpolatory abscissas. And that's what I'll try to show next time. I'll show you a MATLAB implementation of examples 3.1, probably 3.2, and so on. Okay. And overtime na naman pala ako ng 12 minutes, so sorry about that, guys. So pag nag-overtime pala ako, you can leave the meeting and just look at and then just watch the recording. Pero if you have time and you still have data, siguro magstay tayo hanggang mga 9:30, 9:35ish. Kasi ang next period naman yata ay 10 a.m. Okay? So let me see. So sino nga may mga plus 1? Si Denmark lang at saka si Lyra, no? Lyra plus 1. Ilalagay ko na lang sa chat para ito na lang yung hanapin ko next time. Okay. Any questions?
Sir, ask ko lang po. So, yun po yung pinaka main reason kung bakit po na-minimize yung ayun po, yung value po is because siya po yung may pinaka minimal value of L infinity norm.
Yes. Kasi remember, ang goal natin ay mapababa yung L infinity norm ni omega. Kasi anong alam natin kay omega? Si omega ay monic polynomial of degree n plus 1. Tapos naggawa tayo ng analysis. Ang results ng analysis natin ay ang may pinakamaliit na L infinity norm ay yung mga Chebyshev polynomials, yung mga monic Chebyshev polynomials. So para ma-attain ni omega yung pinakamaliit na L infinity norm, dapat si omega maging equal sa monic Chebyshev polynomial. Right? Pero si omega, ito yung itsura niya. By definition, ito yung itsura ni omega. Pero gusto kong maging equal to sa t hat sub n plus 1. Kasi nga, ang may pinakamaliit na L infinity norm ay yung mga monic Chebyshev polynomials. Wala nang iba. Sila lang yung nakaka-attain ng minimum L infinity norm. Okay? Parehas silang monic. So, ibig sabihin yung roots ng omega, ano ba yung nagpapa-zero sa omega? x1, x2, and x sub n plus 1, which are the interpolatory abscissas. So kung yung mga x subies, gagawin kong equal dun sa mga roots ng monic Chebyshev polynomial, then omega will be equal to t hat. So dahil magiging equal sila sa isa't isa, makukuha, mai-inherit ni omega yung pinakamaliit na L infinity norm, which turns out to be equal to 2 to the negative n ng t hat sub n plus 1. So ang bottom line dito ay yung mga interpolatory abscissas, kailangan ko lang silang gawing equal dun sa roots ng monic Chebyshev polynomial. And we won't have any big problem about that kasi dun sa remark 3.1, alam na natin yung roots ni Chebyshev polynomial. So kung nag-interpolate ka pala on the interval negative 1 to 1, kapag ka yung mga x subies, yung mga interpolatory abscissas, ay ginawa kong equal dito, sure ako na makukuha kong omega or yung factor dun sa error term will have the minimum L infinity norm, which is equal to 2 to the 1 minus n. So ibig sabihin yung error, magiging f to the n plus 1 of psi all over n plus 1 factorial. Hindi natin to ginalaw. We're still using n plus 1 points. Pero instead of omega of L infinity norm ni omega dito, pwede ko na itong paltan ng 2 to the negative n. So ang error na ngayon, sure tayo na kapag ang ginamit natin as interpolatory abscissas ay yung roots ng Chebyshev polynomial ay magiging equal dito. At ito yung pinakamaliit na L infinity norm that we can do with n+1 data points. Okay? So I hope that answered your question.
Thank you po, sir. Follow up ko lang po. By theory po ba na yung Chebyshev po yung may pinakamaliit na L infinity norm? Or in the future po, if we have to prove po, do we still have to prove na siya po yung may pinaka-minimum na L infinity norm? Or as is na po?
As is na yun. Yun yung pinrove natin sa 3.1. So, by Theorem 3.1, yung monic-Chebyshev polynomial, siya na yung may pinakamaliit na L infinity norm. So, hindi ko na ipapaprove sa inyo yan sa problem set kasi nandito na yung proof. So,
Okay po,
may
sir.
kinorek lang yata ako na konti. Pero yeah, I mean, konting typo. Pero ito na yung proof. Ito yung sinulat natin dito. So from now on, pwede nyo nang paniwalaan at i-quote na may pinakamaliit na L infinity norm ay yung mga monic-Chebyshev polynomials.
Thank you po, sir. Yan lang po yung questions ko pa.
Okay, you're welcome. Any other questions? Mukhang si Lyra lagi yung alay sa mga questions, ha? Kasi napapanood ko yung lectures ni Sir Jacob. Siya rin yung madalas nagtatanong. So hopefully I'll also hear from the others as the semester goes on. So if there are no other questions, sorry, overtime na naman, but thank you all for coming and staying. So I hope you enjoyed the rest of the day, and let's see each other again on Thursday. Bye, everyone.
Thank you po, sir.
Thank you po, sir.
Okay, you're welcome.
Thank you po.